My name is Luka Čičin-Šain. I am the head of the Department of Viral Immunology at the Helmholtz Center for Infection Research, and I am also the coordinator of the research topic Infections and Immune Interventions. We look into the interaction of the virus and the immune system and how the presence of a virus may affect the immune system. It is kind of clear that the immune system is there to hit the viruses, to control them, to help us in the fight against them, but it's less understood how the viruses are fighting back and how they are affecting our immune system, how they're changing it. So that's what we are trying to understand, because then we can appreciate how a person that is infected with an otherwise common virus chronically, like a herpes virus, may behave differently than a person who is not. And this is important. A lot of people are latently infected, and for a lot of them this makes a difference. Here we particularly are looking at the cells from people who are latently infected with a specific herpes virus called the cytomegalovirus. In Greek it literally means the virus of the big cells, because the cells get big when you're infected, yeah. But the important thing about the virus is rather the clinical relevance. And it's underappreciated that this is a really common virus that is causing malformations if infection happens during pregnancy. In fact, it's more common than the German measles. German measles are controlled by a vaccine. There is no vaccine against cytomegalovirus, so it's the most common infectious cause of malformations nowadays. And we wish to understand it better. So we wish to see what it does to people that have it in their body when they're growing older, how this may change their metabolic diseases because of the presence of this virus and its effect on the immune system. Or also we wish to understand how it may impair the immune response to other infections, for instance, if the people get infected with influenza or with the coronavirus. You have all of this plethora of potential pathogenic risks that we are exposed to. We live in this dirty environment, and yet we manage to survive and thrive, and we find a way how to deal with all of that, except sometimes we don't. And sometimes we get sick. And now this is the question, why does this happen this way? So understanding the basis of all of these good and bad outcomes, and then being able to act on them, learning how we can do it better is what is my daily job and the job that I love. I used to be a medical doctor before I went into science. So I'm a basic scientist right now, but in the cluster I can work together with the clinicians. And the clinician scientists, together with our basic scientists, can do so much more. We provide them models. They can provide us access to patient samples or patient data. So together we can answer these questions of societal relevance that neither of us could do alone. And that's obviously something that is a benefit when different kind of expertises are pulled together.